Hello, my name is Jung-Ho Ju, and I will present the recycling presentation. I choose the changes in the agricultural manufacturing process in the future following the fourth industrial revolution. Originally, I was going to make a presentation about a vertical farm, but another friend was so good at presenting that I had nothing more to do. As a result, the presentation area was expanded throughout agriculture. Then I will start. This is contents. I will give an overview first and then explain the fourth industrial revolution and agriculture. Next, after explaining the changes and example in the agricultural production stage following the fourth industrial revolution, the conclusion and future prospect will be mentioned, and the presentation will be completed. The fourth industrial revolution following the invention of steam engines, mass production, and the information technology revolution is remarkable in the extension, speed, domain, and the system of third industrial revolution, and is based on artificial intelligence, big data, and the Internet of Things. Unlike third revolution, which moved passively according to pre-entered programs, machines voluntarily making judgment and perform tasking according to individual process depending on the situation. Although GPS systems have been used on the best American farms since 1997, the overall application of the revolution in the agricultural industry, also called Agriculture 4.0, has progressed slower than other industries. However, since 2017, research and application of precision agriculture using the Internet of Things (IoT) and the big data have been speeding up, and drones, robots, and autonomous tractors equipped with artificial intelligence (AI) technology have been developed and applied through the agricultural process. By linking software with advanced instruments that enable automation, it collects data and analyzes the situation and deliver it to farmers as well as major functions such as sowing, water supply, nutrition injection, harvesting, and weeding. In the early 18th, 300 hours of working hours were required to produce 100 bushels of wheat, but now 100 bushels of wheat can be produced within an hour with the use of technology such as AI. This suggests that productivity per capita, permanent productivity, and hourly productivity all increased significantly through the fourth industrial revolution. Efficient systems through the fourth revolution reduced the poverty and the waste on Earth and preserved the Earth's environment. World food production four times more between 1960s and 2010s due to the advance in technology and trading along with the first, second, and third industrial revolutions. While oversupply led to drop in agricultural price and a bad impacts on environment. In addition, food-related disease decrease have emerged as a major cause of early deaths, even though production is following population growth. Due, due to those overall problems, the issue of whether the fourth industrial revolution technology produces more food, protect the global environment, provide balanced benefit to producers and consumers, and help with healthy eating habits and transparency of food has emerged. This is not limited to the agricultural industry, but also related to the overall distribution system such as supermarkets and online sales system. It is said that the management of the agricultural production and distribution through the fourth industrial revolution and the big data will reduce the waste of resources, benefit agricultural industry officials, and contribute to a balanced and healthy food supply by enabling efficient and transparent food production and distribution. The environmental problems accompanying agricultural production and consumption are serious, and the modern eating habits and the food productions of 7.6 billion humans destroy the marine and continental environment, leading to water shortage and climate changes. Adjusting to climate changes is a continuous problem in agriculture, and extreme climate adversely affects harvest due to temperature rise and atmospheric change. A recent study by the National Academy of Science found that a rise in Earth's temperature by 1 degree Celsius reduced corn harvest by 7.4%, wheat by 6%, and rice by 3%. Even though accurate sowing supply and demand and harvesting also threaten the harvest of factors such as flood, drought, and pests. So predicting and preparing for climate changes through big data and AI helps farmers prepare for national and natural disaster and solve problems. Precision agriculture contributes to the sustainable environment. The fourth industrial revolution will significantly reduce the cost of connecting consumers, suppliers, and producers, and increase efficiency in exchanges between upper and lower markets and the industrials, leading to the higher price of agricultural industries and competition among intermediates. In addition to the benefits of supplying sufficient food to mankind while preserving the environment, the fourth industrial revolution is expected to provide many business opportunities. Changes are also taking place in the agricultural sector due to the fourth industrial revolution. Here is the collection of keywords for the changes: visualization, self-decision, big data, Internet of Things, IoT, artificial intelligence, AI, robots, driverless tractor, drones, 5G technology, smart agriculture, precision agriculture. Total 11. Farms using big data and gaining cost saving using IoT and satellite technology. And farmers analyzed farm situations that cannot be visited and checked in person by viewing satellite images of tablet pieces and visiting problematic places. Satellites also have to accurately identify and take action on the best farm, enabling precision agriculture that saves fertilizers and resources and minimizes time and manpower. Through drones, or farmers' hopes of seeing farms on the air are realized at low price without using expensive helicopters. In addition to photos, moving real-time images can be viewed freely in various attitudes and directions and provide both infrared rays and high-spectrum images. High-definition images allow the farmer to collect more detailed data, monitor crops condition, evaluate soil quality, plan appropriate use of sowing location and materials, and maximize soil use. Those farm surveys improve the sowing, irrigation, plan, and the three-dimensional mapping. And through those data, farmers maximize all aspects of crops and land management. In addition to imaging, drones are developed to sow and spray. For example, it performs the function of spraying seed, fertilizer, and nutrient directly, nutrient directly into the soil through the compressed air. GPS and self-driving battery systems began in the early stage of agricultural revolution and have led to innovation in farm management over the past 20 years with precision agriculture and automation. The observation, surveying, and response system of various farmland according to gain have evolved, maximizing the use of the equipment and enabling fertilizers, water, and pesticides. Egbot, a farm robot, has emerged as being used in various processes as standardized operation process, which is labor-intensive and respective, tend to be replaced by automation. Ultimately, new smart equipment enables more production with less labor. Following the automation of tractors in 2016, a system that can receive weather information from satellites in real time and perform all tasks independently even when it is not managed by human has been established. According to CNH Industrial, a farm equipment company. Instruments on farms communication with each other in real time through streaming data from the cloud, helping farmers communicate with multiple machines. Currently, communication between machines takes 30 to 60 seconds, while data exchange is possible within 1 second with 5 technology is applied. Currently, it takes more time, when possible, to connect 5G in rural areas with many trees and low population density in the United States. But if the technology becomes common in the future, the agricultural revolution will take place quickly. The Industrial Revolution has also brought about significant changes in the production methods and system of livestock farms, resulting in less manpower, allowing livestock to produce more healthily and higher production. New strategies enable precise management, and the benefit of technology accelerate production and strengthen market competitiveness. Livestock identification is a very important part of livestock farm management, including owner certification. physiological safety, code management, efficient farm management, registration, insurance. An automatic recognition system is largely applied in two ways. The other is event records, such as health status and the childhood record, and the automatic identification system collects and stores simple records and show them according to the livestock code. It works in conjunction with RFID system. The voluntary milking system allows cows to selectively approach the milking machine, and when cows access the machine for feed intake, only cows that can be milking through the electronic tag system pass through the smart gate to proceed with milking. Robots that provide automatic meals to livestock are designed to load feed or hay on block or disc, cut hay and provide accurate meals. Through automatic feeding robots, livestock is programmed to receive different meals accurately for each group. Feed and hay are stored for several days to reduce farmers' working hours, which are in the form of hanging or wheeled robot. Finally, recognizing the optimal time for artificial insemination is 16 hours after the start. This system allowed farmers to prepare 4 hours before the optimal time. Crafton, a farmer at Crafton Farms in Portland, Tennessee, which has been operating farms since the 18th, realized that the current fourth revolution has made a leap forward in the farm industry than the first, second, and third revolution. It is that the drones, satellite images, and precision agriculture are helping reduce expense and harvest, and is making significant changes to his 2,500 acres Crafton farm. Changes in the agriculture industry due to the development of technology are set to measure the moisture of soil by applying a wide range of IoT sensors by agricultural equipment, and drones are checking the situation of grains. The Agriculture Center for Research and Education at Purdue University in Indiana continues to support engineers while continuing to study ways to increase harvest efficiency. Active industry academic linked research is being conducted, such as supporting vertical farming, which is operated while significantly reducing carbon footprint in San Francisco's indoor farms. In May 2018, a farmer in Bondurant, Iowa, utilized a precision agricultural system connected to large autonomous tractor on thousands of acres of farms. Tablet PCs, touch screens, and control panels are installed in the harvesting tractor to check whether sowing is ready, and the tractor is automatically operated and sowing is performed by entering sowing conditions. The Bright Cotton Company has been run by many farmers on 3,500 acres of farms during low labor. However, as the Diesel fuels becomes more expensive and rural personnel begins to leave the region, changes in farms becomes essential. Recently, the benefits of Industrial Revolution technology have maximized the labor force of 5 people through cooperation with organizations and technologies, and have developed again due to changes in the organic market. In farm operation, an increase in net profit along with an increase in yield is an important factor, and reducing the previous 12 to 20 hours of workers a day while increasing net profit and increasing leisure time at home were also important benefits of technological development. Hydroponics is cultivated with a small amount of soil or neutral water and is associated with organic farming in the most indoor farms. The software records the cultivation condition and growth of individual vegetables and fruits and manages data. Vertical farming is also farming method to make a most of narrow indoor space or greenhouses, and in most cases, chemical-free cultivation using neutral water is carried out indoors. Vertical farm facilities are monitored and harvested by robots. Ecological agriculture, biofarming, is based on measuring the condition of microorganisms in the soil and applied microorganism nutrients and components necessary for the soil in the balanced manner. It mainly grows natural organic products with no chemical ingredient. Technology was introduced into agriculture as a green revolution after World War II, and productivity was remarkably changed with harvest seeds, agricultural chemical power generation, fertilizer, pesticides, herbicides, etc. Irrigation, agricultural mechanization, industrialization of agriculture, and GM gains. On the other hand, the cost increase, pollutant generation, increased resistance to herbicide and pesticides, and environmental destruction may occur. Minimizing environmental destruction and maintaining ecological diversity while increasing productivity in existing farms has emerged as a challenge, and the fourth industrial revolution is expected to overcome the crisis of traditional agriculture. According to a report by U.S. Department of Agriculture (USDA), blockchain technology, which is part of the fourth industrial revolution, is applied to the agriculture sector, enabling data sharing, real-time information, and developing programs that can be used for actual agriculture. In addition, Driscoll's blockchain Green Onion Test project, a large food production manufacturer, is being promoted for food safety under the concept of farm to store, with Walmart and IBM, a large distribution chain. Through this, consumers can now harvest data, product information, and delivery information by attaching traceable labeling (PTI) and used blockchain technology to predict demand and plain crops using vegetable DNA, managing inventory and cost, and provide transparent information to consumers through GPS, thermometers, ERP system, and refrigeration systems. Adaptation to farm and consumer data and how to achieve a healthy, diverse, competitive, and environmental agri-food economy are not just a matter of technology. As the policy directions has been established and the intermediate need has emerged, the industry is currently watching the U.S. Department of Agriculture's draft, which is somewhat ambiguous in this area. As described above, the fourth general industrial revolution and the changes in the agricultural manufacturing process were outlined. In the future, agricultural technology is expected to achieve tremendous developments along with the technologies of the fourth industrial revolution. However, what should not be forgotten is whether it is sustainable development. It must also check the right direction about the degree of change in agriculture and how to distribute balance. Individual revolution benefit to small business, agriculture producers, large food companies, and consumers. This is the end of the presentation. Thank you very much.